Now we're getting into the very important concept of consumers. So we know about producers, but now things need to read data, so here's consumers. And as we said, consumers will read data from a topic, and the topic is going to be identified by its name. The consumers, they know which broker to read from automatically. It's already programmed for you. And in case of broker failures, just like producers, the consumers will know how to recover. So this is already done for you. You don't have to think about these. Data overall will be read in order within each partition. So we'll see that means right now. So we have broker 101 and topic A, partition 0, and we have a consumer reading from it. It's going to read data. So as I said, it's going to read data in order. So it'll read message 0 or offset 0, then offset 1, offset 2, etc., up to offset 11. So as you can see here, the data is read in order. The consumer will not see offset 3 before seeing offset 2. So it's really important to understand that. Now, consumers can also read from multiple partitions. So in this example, we have another consumer, and it's reading from partition 1 of broker 102, and it's reading the data in order for partition 1, but it's also reading the data in order for partition 2, okay? But as you can see, there's no guarantee across the order between partition 1 and partition 2. It reads them in parallel, okay? So the actual mechanism, some students ask me this, is that it will read a little bit from partition 1, then it will read a little bit from partition 2, and then a little bit from partition 1, etc. So there's no specific order, and you can see offset 5 appear on partition 2 before partition 1 or the opposites. There's no guarantee, okay? But the bottom line is the data for each partition, within each partition, it's read in order. Now, how do these consumers read data from all the partitions, etc.? There's a concept of consumer groups. And so basically, you're going to have a lot of consumers, and a consumer is basically like a Java application or whatever language you're using, and they will read data in groups. And each consumer within a group will read directly from exclusive partitions. And if you have more consumers in partitions, some will be inactive. We'll see this in the very next slide. So here's an example. We have our topic A, and it has 3 partitions. Now we have a first consumer group, and a consumer group represents an application. So for example, this is my dashboard application, and I have 2 consumers, okay? Well, the consumer 1 is going to read from 2 partitions, and the consumer 2 is going to read from the 3rd partition. And so as you can see, this was the example just like before, consumer 1 reads from 2 partitions at a time, while consumer 2 just 1 at a time. Now we have another application, maybe it's an analytics application, and this one has 3 consumers, and so the name of the consumer group is whatever you want to name it, but we'll name it consumer group application 2. In this case, each consumers will read from 1 partition only. And finally, say we have a 3rd application, okay, that's maybe our notification service, and we have 1 consumer only. Well, that 1 consumer is going to be reading from the 3 partitions at the same time, okay? So as you can see, the work is divided. But what happens when you have more consumers and stuff? So just before we do this, just know that the consumers, they will know exactly how to coordinate and how to go to which partition automatically, and using the group coordinator and the consumer coordinator. It's not something you have to program, it's a mechanism already implemented in Kafka, and we'll see a demo of it. So what if you have too many consumers? Well, if you have more consumers than partitions, as I said, some consumers will be inactive. So here's an example. We have 4 consumers in our application, and only 3 can read from partitions because we only have 3 partitions to read from. So the 4th consumer is here to be inactive. Now, sometimes you may want that because say you're going to lose consumer 3, like the application just stops or the machine shuts down, then consumer 4 can take over right away. This is the only case where you would want this, okay? But usually you don't have inactive consumers, you just have as many consumers as partitions at most. And so that's why it's so important when you choose a number of partitions for your topic. If you want to have a high number of consumers, you need to have a high number of partitions. So this is a decision that you have to make, okay? In this example, we have 3 partitions, so we can only have 3 consumers max at the same time in a consumer group. Otherwise, others will be inactive. So I hope that helps. We'll see again all these concepts in the hands-on when we start getting our hands dirty, but at a high level, they should make sense. And if you have any questions, wait until the hands-on, okay? And I will see you in the next lecture.